Okay, so this is electron configuration. This is where we're going to give all the electrons homes. An orbital diagram uses boxes with arrows to show how the electrons are arranged in orbitals. And so we're going to draw some orbital diagrams. First, we'll do lithium. We look at lithium on the periodic table right here. Its atomic number is 3. That means it's got 3 protons. Each proton has positive charge that has to be equaled by a negative charge. And so lithium is going to have 3 electrons as well. We have to find homes for 3 electrons. We're going to start with the lowest energy level, and we said that the lowest energy level was a 1, and that energy level only had 1 orbital in it. Get a different color out here. And we're going to put 2 electrons in that orbital. The next, and notice one goes up and one goes down. That's supposed to indicate the opposite spins. We'll write that this is lithium. The next highest energy level will be a 2s. And we have 1 electron left, and we'll put it in the 2s. So let's do carbon next. Carbon, the periodic table here, has 6 protons, and it'll have 6 electrons as well. So we've got 6 electrons to place. The first energy level is 1s. The next energy level is that 2s. And if you'll remember, we also said that there's a 2p. In fact, we said there were 3 2p orbitals. And the 3p orbitals all have the same energy, so we draw them connected. So there are our orbitals. We need to place 6 electrons. We need to start with the lowest orbital first, and we'll put 1 with 1 spin and 1 with the other spin. Each box can hold 2 electrons. The electrons are the arrows here. So that's 4. We have 2 more to place. Electrons hate each other. So given an option of 3 equivalent orbitals, they will go by themselves. It only works if the orbitals are equivalent. And then let's do sulfur. Sulfur on the periodic table is right here. We're going to have 16 electrons to place. We'll be writing a lot of orbitals. We'll have a 1s. We'll have a 2s. And we'll have our 2 p's, and there are 3 of them. Okay, now we'll have to go up to the next level because there are not enough orbitals here for all 16. So the next one up would be a 3s, and then we'll have the 3 p's. There are also 3 Ds up here, and there'll be 5 of those. We're not going to need those, but we can draw them here. Just for completeness. Okay, there, now you can see. Okay, so we're going to put 16 of them in. We'll start with the lowest energy. One goes up, the other goes down. Goes up, so they have opposite spins, each one holding 2. Okay, these like to spread out. 16, we've got 2, 4, 5, 6, 7, 8, 9. So that's 10, 11, 12, Then these like to spread out again, 12, 13, 14, 15. But we've got one more, and we'll put it here, 16. So a couple things to note. One is if they have equivalent energy shells, like these 3 P's, the electrons will spread out. The other thing is that they will match spins. If there are 2 that are by themselves, they'll both be up or they'll both be down. Okay, so that's the orbital diagrams. As you might guess, it gets to be a real pain to draw all these boxes and get them all labeled. And so generally what you'll see is electron configuration. An electron configuration indicates the placement of electrons in an atom. And it looks something like this. 1s2 means on the first level in the s orbital there are 2 electrons. 2s2, second level, on the s orbital there are 2 electrons, and 2p2 would mean on the second level in the p orbitals there are 2 electrons. So the superscripts are the number of electrons, and the big numbers are the levels. And we're going to do this really easily by using the periodic table. The first 2 columns of your periodic table are going to be the S block. The transition elements are going to be your D block. Your P block is going to be the last 6 columns of the periodic table. And the D block is the one that floats here down below. Let me show you how we're going to do this. Okay, well, first a little note, you're not responsible for the oddities. There's some atoms that don't really follow the rules. We're not going to pay any attention to them. Okay? Okay. So the first thing we want to do is we're going to take helium and we're going to put it over here. Then we're going to make this our S block. This is our P block. And this is our D block. Down here we have F. Okay. Then we need to put the periods on it. This is the first, second, third, fourth, fifth, sixth, and seventh. The D block is 1 off. So right here with titanium and vanadium, those are 3D. And so this is 4, 5, and 6. Okay, so let's do carbon first. It's kind of a short one. We first need to find the carbon on the periodic table, and it's right here. And then we're going to just read the electron configuration off. 1s, start at the very top, 1s. There are 2 boxes there. That means there are 2 electrons. Then we go, there's nothing else on the first level, so we go to the second level. The second level is 2, and these first 2, lithium and beryllium, are in the S block, so we'll say S, and there are 2 of them. And then we go over here. This is also 2, but now we're in the P block, and we have 2 boxes in the P block, so that's 2. And that's the electron configuration for carbon. So let's do the same thing, except this time for gallium. So we want to find gallium on the periodic table. It's right here. We want to note that we want to move our helium over. This is the D block. This is the P block. And I did not leave myself a spot, but we'll scoot that just a little bit, and there are S block. Okay. Then we want to put our numbers 1, 2, 3, 4, 5. Remember, the numbers here are one less than the period number, so we put a 3 and a 4 here. This periodic table has been abbreviated just to give me more room to work. All right, so we'll start at the very top, and this time I'm going to draw a line through it as we go. These two are 1s, and there are 2 of them, so it's 1s2. And we're ready for the second column, second row. Those will be 2s2. And here we've got 2. This is the P block. And there's 6 of them. 1, 2, 3, 4, 5, 6. Then we're ready for the third row. We get 3. Those are S's, and they're 2 blocks. And there's a 3, P6. Then we come down here, we've got 4, S2. Then we have a 3, D, and there are 10 boxes here. 1, 2, 3, 4, 5, 6, there should be 10. And now we're to gallium, but we've got one more to put. We'll have a 4P1, and that'll be gallium. Now, that's a lot to write out. And so you can go back and substitute for all this. We can substitute argon, and this gives us an abbreviated. We come back to here. The 1s2, 2s2, 2p6, 3s2, 3p6, that is the configuration for argon. So you can go back to the next noble gas and just substitute and put argon for that, and then you just have to write 4s2, 3d10, 4p1. And that makes it a lot shorter. You can do that with any of them.